Welcome to video 12.1. Today we're going to be talking about the fundamental counting principle and permutations. So the objective for today is to use the fundamental counting principle to count the number of ways any event can happen, and to also use permutations to count the number of ways an event can happen. So let's look at the idea of owning a small deli. If you own a small deli, you would offer 4 types of meat. You'd offer ham, turkey, roast beef, and pastrami. Now, along with that, you have 3 types of bread. So the question is, how many choices do your customers have for a meat sandwich? Well, for each meat, there are 3 possibilities. So for the pastrami, you can have white, wheat, or rye. For the roast beef, you can have white, wheat, or rye. For the turkey, same thing, you have 3 options. And for the ham, you have all 3 options. So the question is, how many choices do your customers have for a meat sandwich? Well, there was 4 choices for bread, for meat, and there's 4 choices for bread. So, mathematically, we know that total there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, or 4 times 3. So there were 12 different choices. So this is an example of what the fundamental counting principle is. Now, the formal definition of the fundamental counting principle goes as so. So if there are 2 events and one event can occur in m ways, so let's use the meat example. We had 4 types of meats, and another event can occur in n ways. So we had 3 types of bread. The number of ways that both events can occur is m times n, 4 times 3, which was 12. Now for 3 or more events, it's the same idea. Let's say there was 3 types of dressing. If we wanted to figure out how many different possibilities it would be, what we would do is m times n times p. So there would be 36 different types of meat sandwiches you can get if there was 3 types of dressings. So let's look at some criminology examples. So police use photographs of various facial features to help witness identify suspects. One basic identification kit has the following parts in it. We have 195 hairlines, 99 eyebrows and eyes, 89 noses, 105 mouths, and 74 chins and cheeks. So the developer of this identification kit claims that it can produce billions of different faces. Is that claim correct? So what we want to look at is we want to see if this combination can provide over 1 billion different faces. So simply for here, what we do is we multiply all these possibilities. So 195 times 99 times 89 times 105 times 74. And we do that, we get 1.3 times 10 raised to the 10, which is over a billion. So that developer was correct. So now you have a witness that comes in and says they can clearly remember the hairline and the eyes and eyebrows of a suspect. How many different faces can be produced with this information? Well, if that's the case, then he knows, since he already knows the hairline, that gives us 1 option for the hairline. And he knows the eyes and eyebrows, so that's only 1 option for that. So from there, we still have the noses, the mouths, and the chins and the cheeks. So it's 89 times 105 times 74, which gives you a total of 691,530 faces. So New York City license plate have a standard configuration for their plate design. Now in this design, they always have 3 numbers followed by 3 letters. So the question is asking us how many different license plates are possible if digits and letters can be repeated. So we have to treat each spot and figure out how many possibilities there can be. So for all the numbers, there are technically 10 possibilities because the numbers can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So for the first 3 spots, the possibilities are 10 by 10 by 10. These are for the numbers. So for the numbers, you can do 10 by 10 by 10. Now for the letters, we should think about how many letters there are in the alphabet. And there are 26 letters in the alphabet. So for each of these spots, there's 3 options. 26 times 26 times 26. So we multiply all of this together, we end up with 17,576,000 possibilities. So that was part A. Now part B is asking us how many different combinations can we have if the license plate digits and letters cannot be repeated. Now this is the same idea, but we need 3 numbers and we need 3 letters. So for the first one, since there's technically no numbers that can be repeated for the first term, we have 10 options. Now for the next number in the sequence, we've lost a number. So we have to multiply it by 9. And we've lost 2 numbers, so now there's only 8 options. Same thing goes for the letters. For the first letter, there's 26 options, then there's 25 options, then there's 24. And we multiply all these together, we end up with 11,232,000 options. So a permutation is an ordering of objects. So for my set of 3 letters here, there are 6 permutations of these letters. So A, B, C would be the first one. I can switch the A, the B, and the C. I can switch A and B. I can switch these as well. BCA is an option, and CBA is an option. So there's 6 permutations of this letter. Now, in general, we want to figure out the permutations of distinct objects, and we'll talk about what distinct means later. We use this N, this exclamation point symbol, but we're going to call that N factorial. So we're going to use that exclamation point. We're going to call it the factorial. So in this example, we have 3 objects. So if I want to figure out the number of permutations, what it would be is 3 factorial, which is 3 times 3 minus 1, which is 2, times 3 minus 2, which is 1. So there's 6 options. So let's work on finding the number of permutations. So we have 12 skiers competing in the final round of the Olympic freestyle skiing competition. We want to figure out how many different ways the skiers can finish the competition, assuming there are no ties. Well, for this, we use our factorials. So there's 12 skiers, so we use this 12 factorial to figure out what this is. Now, I don't expect you to do this by hand. In your calculator, you can find the factorial symbol, and it'll do all this automatically for you. So we just work through all the numbers till we get down to 1. We multiply all these numbers together, we get 479,001,600. In the second part of this problem, we want to figure out how many different ways 3 of the skiers must finish first, second, and third to win the gold, silver, or bronze. So for this one, the first we have 12 possible skiers to finish in gold, silver, or bronze. But then after that, we've lost a skier. So we only have 11 left for the silver. And then for the bronze, we have 10 left. And multiply these together, we get 1,320. So if we want to figure out how many possibilities we can have from a certain amount of objects, we have to use the equation for the permutation of n objects taken at a time. So in this, n is going to represent the options. And r is going to be what we select. So in this problem, we're considering 10 different colleges. Before you decide to apply to all the colleges, you want to visit some or all of them. And how many orders can you visit 6 of the colleges? Well, let's see. We have 10 possible options. So we're going to multiply 10 by the factorial and divide it by n minus r. So we know n is 10, r is going to be 6. 10 minus 6 is 4 factorial. Now once again, don't do this all by hand. Find the factorial symbol on your calculator. And when we do this on our calculator, we get 151,200. Now if we want to visit all 10 colleges, we do 10 P10. Still the same idea, but now since the amount of colleges equals the options, what we're going to end up with is 10 minus 10 factorial here. So we end up with 0 in our denominator, so it's just 10 factorial, which equals 3,628,800 options. Now, in some scenarios we'll have permutations without repetitions, other times we'll have permutations with repetitions. If there is a repetition, we want to talk about the formula for permutations with repetition. Now, the number of distinguishable permutations of n objects, remember, we said n is going to be all of our options. Where one object is repeated Q1 times, another object is repeated Q2 times. We will use this formula here. Now I want to do this one together in class, so just copy down all this information, and that'll be the end of this video. So I hope this was helpful. Once again, thank you and take care.